finish up with one of these from the notes. All right, we're told these are similar. The ratio of the sides. The ratio of the sides was Jackson. Yep. What's the ratio of the sides on this one? 10 to 5, which reduces into 2 to 1 or 1 to 2, depending on which way you're going to go. 10 to 5, which is either 2 to 1 or 1 to 2. And as soon as you pick which ratio you're going to use, you're kind of forcing yourself to set up the rest of the problem with either your bigger number up top or the smaller number up top, depending on which one of those you use. All right. What's the ratio of the areas? It's the ratio of the sides squared. What's 1/2 squared? 1/4. So 1/4 is our ratio of the areas. And again, this is another one with easy numbers. You probably do not need to set up the next proportion. We're going to do it to develop good habits so that when you get into a messy one, it's easier. All right? So you always, if you're looking for the area, set up the proportion with 1 to 4 or 4 to 1. 1/4 equals, and since the little one went up top, 1, and the bigger number went at the bottom, 4, then the little triangle's area, whether I know it or don't, has to go in the top. The little triangle, it's the area we're trying to find, right? So we call it A. And what is the area of the big triangle that we know? 36. Cross multiply, solve, 4A equals 36, divide by 4, area equals 9 square centimeters. Again, I know you can just multiply by 1/4, 36 times 1/4, and get the smaller area. Tell.
Do we have to use a capital A for the variable?
I would. Reason is because when we head in, like as we can move through geometry this year, little a lot of times is going to be called a side length in a right triangle when we do the Pythagorean theorem. So it's just a good habit of calling area capital A. All right, these numbers were too easy. I'm going to change it. Are you ready? Make a new problem. Then we'll move into the 8-2 notes. Whoa. Let's do 6 centimeters. The bigger triangle now has a length of 6 centimeters. Go ahead and find the ratio of the sides, the ratio of the areas, and find the missing area of the little guy. All right, help me out. Did you all get 36 25ths or 25 36ths as your ratio of the areas? How many of you got that? Awesome. So 36 over 25 equals, does A go up top or in the bottom? Bottom because it's the smaller one, right? We're trying to find the smaller area. Area goes with the 25 down there. And what was the area of the big guy? 36. Just a coincidence that we have a 36 there. All right, I'm going to show you a little mental math trick. 30 cross multiply. 36A equals 25 times 36. I bet a lot of us went to our calculator to type that in. Do you agree? Did you guys go to your calculator to type that in? But look what happens. I didn't multiply it out because what am I going to divide by? 36. And what happens when I divide by 36? That one cancels out. A is 25 square centimeters. Did you get 25? Do you see how to do it with a little bit more complex ratio? Do you see how you probably had to set up a ratio that time?
Yeah.
There you go. All right. That was 8-1. Let's move into 8-2. So 8-2 is called proving triangles similar by angle, angle. Ooh, angle, angle. If two polygons, listen up carefully, if two polygons are similar, their angles are congruent. Their angles are congruent and their sides are proportional. So, in a triangle, what's the minimum number of angles that need to be the same for them to be similar? 2, because if two pairs are congruent, don't all three have to be congruent? So 2 is the minimum, right? We learned the third angle theorem. If two angles in one triangle are congruent to two angles in another triangle, the third angles have to be congruent. So 2 pairs is the minimum. 2 pairs. So that's why we see AA. Is AA a congruence theorem? No. But it's a similarity theorem. So we'll talk about that one. What is angle-angle similarity? Well, if two angles of one triangle are congruent to two angles of another triangle, the two triangles have to be similar.
Yeah. So, like, what's the difference between similarity and congruence?
Size. So congruence, they have to be exact same shape and size.
Yeah.
Similarity, like one could be magnified, but it's the same shape, just dilated.
Yeah.
They're still similar, but they're not congruent anymore because the scale factor might be like 2 or 3. So if you see these arc marks, a pair of arc marks, another pair of arc marks, the triangles have to be similar, same shape. And we use that new symbol from yesterday, that tilde. Is it tilde or tilde?
Tilde.
Because in Spanish, I think it's tilde, right? Because it's a symbol in Spanish, but in English, I don't know if it's pronounced the same or not.
It's not.
What are we talking about?
This thing.
Oh, the thing that goes on top of the end.
Yeah. Did we talk about this in class yesterday about passwords?
Banana, and it has an end.
Yeah. That's a great. You know how you have to use a special character and a password on a computer? The tilde is perfect because it's all up by itself on the left corner by the cube. There's no other special characters around. Nobody ever guesses it. Everybody always uses, exclamation point.
I always use that.
That's what I do. What do you use for you?
Use the tilde.
No.
Nobody will ever guess it.
You're not gonna forget that. I'm not.
It's much more common to use like at
I use that.
All right. Are these triangles similar? Are these triangles similar? Well, they have to have 2 pairs of angles congruent. Do you agree? I see a 90 and a 90. There's one pair. Uh-oh. Say 26 and a 64. But wait. If this angle is 26 and this is a right triangle, what's this angle down here? 64. 64. How'd you know that? We've learned it this year. How do you know it?
Because it has to be 180 in a triangle.
It has to be 180 degrees in a triangle. I agree with that. Use the corollary we learned. If one angle is 90, the other two have to add up to 90. They're press time. He said complementary. Beautiful. Well, guess what? Now we have angle, 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 angle. Okay. Measured angle E is 64 degrees. So triangle. Now let's practice getting our order correct. CDE is similar to triangle. Now match them up correctly. If I started with letter C, didn't matter which letter I started with. Olivia. If I started with letter C, that's the 26-degree angle. What letter do I have to start off with in the bigger triangle? Okay. Then G. Then H. Very good. Bless you. By which theorem? They're similar by A. Angle, angle. All right. Anthony.
Are these coming up on like 2-column proofs?
It's possible. Olivia, don't give him a hard time. All right. Triangle ABE. It's an honest triangle. And ACD. Show that the two triangles are similar. Do you see how the ABE is tucked into ACD? Here's what you should look for. Whenever you see that overlapping, okay, I see angle ABE congruent to angle ACD. That was given to us. We need another pair of angles congruent. Do you see another pair of angles that are congruent? Tyler?
A.
Angle A, very good. Angle A in the big triangle is congruent to angle A in the little triangle because they're overlapping. What property would you say if someone asked you to explain that? Why is angle A congruent to angle A, Jared? Reflexive property. So similar by angle, angle. You could stop at that point because you don't need to show all three sets of angles are congruent. Okay. Next. What do those arrows mean?
Parallel.
Parallel. Very good. When you see parallel lines, think of alternate interior angles. You've got your choice here. Your choice. You could say S is congruent to U. You could say R is congruent to T, and you could actually bypass the vertical angles if you didn't want to. All right. Angle S congruent to angle U. Angle R congruent to angle T, both by alternate interior. So these are similar by a. If you're just torn up over that, you're like, man, there were a pair of vertical angles we just let go. We just let them go. All right. If you really want to say those vertical angles are congruent, you can. Ooh, on to some application problems. A free fall ride casts a shadow that is 80 feet long. At the same time, a person standing nearby who is 5 feet 5 inches tall casts a shadow that is 34 inches long. How tall is the free fall ride? All right. What's something that should be bothering you right now? The extra what? Oh, that bothers you.
Yeah.
Do you know what that's representing? The sun's what? Since when has a shadow been floating up in the air like that? McKenna.
So the small ones in inches and the big ones in feet.
Yeah, that bothers me too. Well, the small one has the height of the person's 5 feet 5 inches. The length of the shadow is just in inches. We're gonna have to do a little bit of conversion. Then you will not get the problem right.
That's okay. That's one problem.
All right. Now, I'm going to convert to feet in this problem. The reason is because the x is in feet. X is in feet. I'm going to convert to feet. All right. So 5 feet 5 inches. That is 5 whole feet and a decimal. 5 whole units, 5 whole feet, and a decimal. Okay? So what is it we have to figure out? How do you find out the decimal? 5 divided by 12, because there's 12 inches in a foot. So 5, we could also say 5 feet 5 inches is 5 and 5/12. Do you agree with that? It's 5 and 5/12. What's 5/12 as a decimal?
5.42.
Is it 0.42?
Well, it's 0.416.
Okay, we'll call it 0.42. That's fine. Everybody okay with that? Take the inches part and divide by 12 to get the fraction of a foot, the decimal expression for that. Next, 34 inches. Well, it's more than 1 foot. It's more than 2 feet, but it's not quite 3 feet. What's 34 divided by 12? 2.83 feet. All right, let's set up a proportion. Who wants? There's a bunch of ways to do this. I'm going to call in someone who's willing to help me out. Who can set up a proportion quickly for us? McKenna's got her hand up.
Well, I'll give it a try, but I'm probably not gonna be right. So you do
That's the attitude. Oh, yeah.
I'm saying the truth, so it would be like x to 5.
That's how I would do it, McKenna.
That's what I thought.
X over 5.42 equals.
80 over. Is that a 2? No,
That's a 2.
It's 2.83.
Beautiful, McKenna. All right. Now, you guys have gotten into some habits over the years. You would say cross multiply here, wouldn't you?
Yes. Why wouldn't we?
I love it.
Can I share with you why?
Yeah.
Okay. Oh, thank you. All eyes up here. Freeze what you're doing. All eyes up here. We're gonna step up a little bit in our mathematical maturity today. All right. Brian, would you close that door for me? Thanks. Do you agree if I multiply? If I cross multiply, all eyes up here. If I cross multiply, this 2.83 comes up and gets tacked onto the x. Do you agree later on we're going to have to divide by 2.83 because now it's multiplied by x? Yes? why can't I just multiply this side and both sides actually by 5.42? Wouldn't that get x by itself? Isn't the goal to get x by itself? Could I multiply both sides by 5.42 and be done with it? Do you understand what I'm saying? It's the same, it's just a step shorter. Because then you don't have to divide by 2.83 later. What's that, Christian? Is there some sassy comment?
No.
Never.
X equals, help me out.
400.
80
Wait, did you?
times 5.42 and then divide by 2.83. I'm getting 153.22 feet. Did you get 153.22, Emma?
I said my proportion up differently and got the same thing.
Yeah, there's several ways you could do it. McKenna chose this one. If other people did it differently, but you get the same, here's what you need to check. If you're cross multiplying, if you end up cross multiplying the same numbers, you're going to get the same answer. Now, what if x is in the denominator? You have to cross multiply because you need to multiply to get x out of the denominator. Do you agree with that? So if you ever set up a proportion where you have x in the denominator, you're kind of forced to cross multiply. All right. We just did one like that. Let's move on. All right. Last couple problems for today. Show that the two triangles are similar. And write a similarity statement. So here's what you need to look at. Do I know which triangles they're talking about? Because I see more than two triangles here. Q, P, R is the one in red. Q, T, P. Q-tip is in blue. What do you guys think?
The big triangle.
Yeah, the red one and the blue one. Are they similar? I have one pair of angles for sure, the 90s. Can I find another pair of angles that they have congruent to each other? Which one?
Q.
Q. Do you agree? Isn't Q overlapping in both? Yep, reflexive again. So triangle QPR similar to triangle QTP by angle. And this is where I bet a lot of you would prefer to either have like a colored pencil or something, I don't know, to maybe outline those triangles because sometimes you won't see the overlap until you kind of outlined it. The picture can kind of get confusing, it can kind of get jumbled if you don't outline them. If nothing else, take your pencil and physically trace over them so you can see what it is that's happening here. Next one. It's a 905. Oh. All right. 80. Got to use the vertical angles or else Olivia will get mad. Storm out. Soberfoot. All right. 80 and 80. Are there any other angles congruent between the two triangles?
Yeah.
Maybe it's not very well.
I don't see alternate interior.
It doesn't say, so we can't do that.
I know. I said you can't.
So why didn't you suggest that?
I would want to find out what the third angles are because they have to add up to 180, right? What's 80? Let's see, 80 plus 35 is 115. 180 minus 115 is, I'm getting 65 for this angle.
Yeah.
Which means this angle needs to be 35. I didn't need to do that because I've already shown a pair of angles are congruent. But they're kind of twisted, right? They're not lined up how we're used to seeing them. So these are similar by angle. Tell.
How do you find angle E?
Do you see vertical angles here? 80 and 35 is 115. This had to be 65 to add up to 180.
Oh, I didn't see.
It's all right. Similar by angle.
We made it. We
Sassy.
didn't go over the bell.
The sass is strong in this one. All right.
I have time to write my homework. No, we had to plug there. We did. Yeah. I used to want to do so bad. Dude, this last quiz
You know what, guys? I'm just feeling. Is it President's Day weekend?
Yes.
I'm just feeling the President's Day spirit. Okay.
Are you deleting all of it? Oh. Okay.
Hold on.
Oh, you're just adding them all back.
All right, Christiana can do them all.
Here's page 6.
And let's see that. That's good. Thank you.
Oh, by the way, if you get out in the first round,